Number 67. A stuntman sitting on a tree limb wishes to drop vertically onto a horse galloping under the tree. The constant speed of the horse is 10 meters per second, and the man is initially 3 meters above the level of the saddle. What must be the horizontal distance between the saddle and the limb when the man makes his move? How long is he in the air? Well, first we need to draw a diagram. Accordingly, we know that the horse is moving at a velocity of 10 meters per second, and that the man is vertically up in the air on top of a tree branch 3 meters. So first we need to find out what must be the horizontal distance from the saddle and the limb. So accordingly, we know the horse is moving at 10 meters per second at a velocity initially. And we know that since it's moving at a constant velocity, that the horse does not have any acceleration whatsoever. However, we still have three variables that we do not know. One of them being time, which is actually mentioned for us to find as another step. And accordingly, with this information that we're given, it's very difficult to figure out for the displacement of the distance between the saddle and the tree branch itself. So we need to go back and try to figure out how long was the man in the air from jumping from the branch in a free fall down to the saddle. Accordingly, we know that since the man is sitting on the branch, he has 0 meters per second as an initial velocity. And since we know that he's moving at a downwards direction, we know that gravity is aiding in his free fall at a constant acceleration of 9.8 meters per second squared. We know that the distance between him and falling down to the saddle will be 3 meters, but in a downwards direction, therefore we have a negative 3 meters as our displacement. When we plug this into the displacement equals initial velocity times time plus 1/2 acceleration times squared, we end up getting 0.78246 seconds. Now that we have this information, we can plug it back into the original equation that we were solving for earlier when stating that what must be the horizontal distance from the saddle and the limb. Accordingly, we can plug it back into displacement equals velocity initial times time plus 1/2 acceleration times squared. And once plugging the time back in, we can solve for the distance and displacement at 7.825 meters.